Vectors. Vectors is among the hardest topic in mathematics. But if you work hard, if you study, if you practice, if you fight, if you endure and do your work, then you will prevail. Let us start by looking at what we call scalar quantities. What is a scalar quantity? The scalar quantity has what you call magnitude. In other words, it has size, but it does not act in any particular direction. For example, if you consider a few quantities such as time, time has a magnitude, a size. You may measure that size in seconds. It could be in minutes, it could be in hours, but you cannot point your finger and says time when 2 hours that way. You cannot do that. Time is a scalar quantity. Another scalar quantity is volume. You may have the volume of a bottle of water. It may be 500 milliliters. That's a popular volume. Some of them are a bit larger and has 690 milliliters. That's another volume. But you cannot then point your finger and say this bottle of water has a volume of 500 milliliters in that direction. You cannot do it. So volume has magnitude only, so no direction. So it is a scalar quantity. If you talk about how bright a bulb is, or not that, how much mass is in an object, mass itself does not have a specific direction. It is measured in kilograms, but it does not act in any particular direction, so it is a scalar quantity. Speed. You don't tell the direction, you just say the speed limit is 50 kilometers per hour. No particular direction given. That is a scalar quantity. the temperature. Now remember, the 50 is the magnitude, but no direction. The temperature, it may be 30 degrees Celsius in the room where you are now, but you cannot give a direction for the temperature. These are scalar quantities. Scalar quantities, and they have magnitude only. Let us now look at vector quantities. Vector quantities. These are quantities that have both magnitude and direction. Here, we're looking, for example, at force. Force is measured in newtons. Let me use N. If you did physics before, you would know that. The imperial measurement unit is in pound, sometimes called lbs. Weight is a force that acts towards the center of the planet, or it could be the moon or some other objects. In other words, in everyday terms, weight acts downwards. So you can always point your finger down and say weight is acting in that direction. Velocity is speed in a specific direction. So you could say the car is traveling 50 kilometers per hour in that direction. So you see, you now have magnitude, pounds, 160 pounds downwards. So you have a direction too. You have a magnitude, 50 kilometers per hour, and you have a direction in that direction. It may be an electric current flowing through a wire. It is 5 amperes, the magnitude, going in that direction. So you have a direction. So electric current is a vector quantity because it has magnitude and direction. Velocity is a vector quantity because it has magnitude and direction. Weight, which is force, is a vector quantity because it has magnitude and direction. You see that? So, those are vector quantities. Now, the vector itself is used to represent a vector quantity. You might have this line. You might also have this line. This line is showing a force acting against a wall. And that force is 50 newtons. This force acting against the wall is 25 newtons. But the question is, right now, in which direction is the force acting? Is it left or right? That is the question for you to answer. If you know that it is acting to the right, then you draw an arrow like this. What we have up here is a vector. This vector of 50 newtons has twice the magnitude of this vector of 25 newtons. You see that? Now, here, you see that the vector of 50 newtons is twice as long as the vector of 25 newtons, because the length of the line shows the magnitude of the vector. So, length shows magnitude. The length shows the magnitude of the vector. You may, for example, have a graph paper where you say 1 newton. You have a scale of 1 newtons. Each 1 newton is represented by 1 centimeter. So this would be 50 centimeters long, and this 25 centimeters long. You see that? If now 5 centimeters represent 1 newton, not that. If 1 centimeter represents 5 newtons, how many centimeters would this be? It would be 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 centimeters long. And this would be half of that, 5 centimeters long. Get the idea? See. Here, you have the magnitude represented by the length of the line that represents the vector. Then the arrow on the vector represents the direction. You can give this vector a name. You can call this vector A, B, so that when you refer to it again, you don't have to draw it. You wouldn't need to draw this vector. You just write vector AB, or just write AB with a line and arrow above it to show that it is a vector. This vector is vector CD. So you refer to that as CD, just like this. You see that? These two letters at the ends must be uppercase letters. Alternatively, you could give this vector a name by using a single letter. It must be a bold letter, single letter, lowercase, that you put at the center. For example, this is vector A. See that? Vector A. The A must be bold, but if you cannot bold it, you draw a little line below it. This is vector B. So, in this case, you use one single letter and call it A or B. A or B. So that's what you have. You see that? Now, we looked at a few vector quantities and the magnitude and direction. There is also what is called a unit vector. Let us look what that is. You may have another vector looking like this. If you want, for example, to find the unit vector of this vector, the unit vector in the direction of this vector, and let us say this vector is 500 units. It may be force in newtons, it may be current in amperes, it may be speed, whatever vector quantity it is. You have to remember your trigonometry now. What you do, form a right angle triangle. Now in this case, this is A, this is B. You see that? Now, a vector has what is called a horizontal component, which is A, and a vertical component, which is B. Now, however, we want to find out what is the unit vector for this. All you need to do is divide the 500 magnitude by 500. You don't have to worry about the A and the B just yet. Because what does unit mean? Unit means 1. The unit vector is a vector that has magnitude of 1. You see that? So 500 divided by 500 is just 1. But then, what you will have here is the unit vector being another vector pointing in the same direction as the 500, and it is only 1. Now we will concentrate on that unit vector. Now, if this vector is acting at say 45 degrees. You want to find A and B. And this is 1. A and B would be the same. So remember now your trigonometry. Pythagoras theorem says A squared plus B squared is equal to 1 squared. You see that? Both A and B would be the same in this case. Since this is 45, this is 90 and this is 45. Call them x. X squared plus x squared equal 1 squared. 2x squared is equal to 1. So therefore, when you check it out, what you will find is that x squared would be half. So x would be the square root of a half. We could find out what that is using our calculator. The square root of 0.5, 0.707, or 0.707. So this would be 0.707, this would be 0.707. Now sometimes the unit vector is referred to like this. This is 0.707, this is 0.707. So that both the horizontal and vertical, if you square each of them, add them, then find the square root, you get 1. So the unit vector has a magnitude of 1. You see that? Now, we will go into this some more, for example, to find other angles like 30 or 60 degrees. But we won't spend too much time on that right now. At a later time, we will find other unit vectors. So, we have the unit vector. This here is just an introduction. Scalar multiplication. What is that about? Let's see. Let us erase parts of the board first. Then we look at scalar multiplication. Now, here, this is our vector right now. This is vector AB. Vector AB has a magnitude of 10 units. The units may be in newtons for force, pounds for force. It may be current in amperes. It may be velocity in meters per second. Whatever it is, it's 10 units. We're going to multiply it by what is called a scalar. A scalar is just a number. It is just a magnitude. So 2 times AB. What is that? We will have 2 times the magnitude of 10, which is 20 units. So here, this new vector, if you call it 2AB, it will have twice the magnitude, which is twice the length of AB. We may call it CD and say CD is 2 times AB. So I multiplied CD. I multiplied AB by 2. you notice it maintains the same direction, but it is twice the magnitude. So you see that. Now, the next thing we want to look at is what if we multiplied it by -2? What would happen? We have vector AB pointing in this direction. It's acting in this direction. It is 10 units. We will multiply AB times -2. We will get a new vector and say this is CD, vector CD. You will get vector CD by multiplying vector AB by -2. Well, since you're doubling the magnitude, you will have a vector that is 20 units long as before, but one difference now. C will be up here and D will be down here, because the direction will change. The direction would have to change in that case. Why? Because you multiplied by a negative. When you multiply a vector by a negative number, the direction changes to the opposite direction. You're going in the opposite direction. You see that? Now, what did we have before? Before all this happened, we had this. Same direction as AB, but when we multiply by a negative, we had opposite direction to AB. Now let's multiply once more. We are now going to multiply CD with AB by -1. We will see that when we multiply AB by -1, we still have the same 10 units, but the direction will change. Now, this vector, if you put back A down here and B up here, you cannot call it AB anymore. You call it BA. Vector BA. Because you state the first letter from the start of the vector, follow the arrow to the other end, and that is where the vector ends with the other letter. So you can say BA is the same as -AB. You see that? BA goes upper right to lower left, AB goes lower left to upper right, opposite direction. So you say these are inverse vectors. The directions opposite to each other. So AB and BA are inverse vectors. Do you see that? So, in this case, again, one more multiplication. If we multiply AB by 3 and we say 3AB, you guessed it, you will have the same direction but 3 times longer, 30 units, because 3 times 10 gives you 30. You see that? So when you multiply a vector by a positive scalar, you maintain the direction, but if it wasn't 1 that you multiplied it by, the magnitude will change. If you multiplied AB by half, you will get 5 as the magnitude, and it will be half as long, and so on and so forth. So you see that. So scalar multiplication, multiply the vector by 2, it doubles, same direction. Multiply it by -2, it doubles, opposite direction. Multiply it by half, magnitude half, same direction, by -half, the magnitude will also half, but opposite direction. You see that? Let's look at equal vectors. Let us introduce another vector. We already have AB. We want to make AB equal to CD. Under what conditions does that happen? We will look at this other vector that is equal to AB, but we also call it CD. AB can also only be equal to CD if we have same magnitude but not only that, also same direction, same magnitude, same direction. So they are equal vectors. Parallel vectors now. What is that about? Well, certainly these vectors are equal. Let's get rid of what we had before. Then we introduce yet another vector. This other vector is parallel to AB, but opposite direction. Therefore, it is inverse vector. Let us call this vector EF. They are parallel, just the same. You see that? So, what happened here is that if you multiply a vector by a number, the answer you get is another vector, and it will always be parallel to the original vector. If the number is positive, it will have the same direction. If the number is negative, it will have opposite direction. You see that? If the number is 3, the vector will be 3 times longer. If the number is half, the new vector will be half as long. So, These are what we've covered so far. Scalar quantities have only magnitude, no direction. Magnitude is the size, how big the vector is, or how small. Vector quantities have both magnitude and direction. You can tell how big it is. You can also point your finger and say it is going that way. So you have a direction. The unit vector has a magnitude of 1. And you can calculate the horizontal and the vertical components of the vector. Where if you have a vector, the horizontal component and vertical components are those where you form a right angle triangle. Horizontal component goes straight across, vertical component goes straight down from the ends, both ends, and then you have a 90 degrees right here. Horizontal component, that is the length of the horizontal, vertical components, the length of the vertical. You can find those and tell what those are. But this is always 1 as long as it is a unit vector. Scalar multiplication. Scalar is just a number. You multiply by the vector. Equal vectors, same magnitude, same direction. If the direction are opposites, then they are inverse vectors. Parallel vectors are in the same or opposite direction. You see that? That will be it for this video. Put your questions, comments, and so on in the comment section.